Hello there, how's it going? So it's going to be a short, quick one, right? So I want to show you about how the Dynamo Nvidia Dynamo really works and what it is about and what does it do. In my last couple of three posts, I think I've shared about what I'm working on this set of technology, right? So here's it. So I think we've all kind of used ChatGPT and Claude, right? For example, if I go to Claude AI and I ask, "Hey Claude, how's it going?" So what happens? There's a couple of processes that goes into place when it comes to LLM inferencing, or when you go to ChatGPT and you ask, "Hey ChatGPT, sorry, hey ChatGPT, how's it going?" So when you send this request, what happens at the back end? What happens in the journey? And how can you do the same? What are the infrastructure that power this? So this is actually what NVIDIA Dynamo is all about. So I think last month I'm a big fan of Google blog, so I read a lot of the blogs post and all of that. And last around September when they released this blog, actually the following day, I read this blog post about the Nvidia Dynamo. That's where I actually got to know more about it in the beginning, and I read about it. I see what they're doing. So I'm much familiar with LLM inferencing in the inferencing ecosystem, and I see, what do you do? What does disaggregated 7 means and what does traditional 7 means? If you're really more interested in about this, I would say you should read more about this blog post. It really enlightens you about what happens at the back end when you send a request on LM server like Cloud or ChatGPT. But if you really want to do your own, maybe for compliance purposes or some agentic applications, and you don't want to send some sensitive data to Cloud or ChatGPT in the server, and you really want to have your own, like an enterprise solutions where you have your own on-prem solution and you want to deploy this solution, I think you're gonna get more value from Dynamo, than traditional users that really use Cloud or ChatGPT. So if you want to deploy your own open source like GPT OSS or Queen 3 models or Llama 4, and all of those OSS models on your own server, how do you go about it? So Nvidia Dynamo is your friend that can actually help you to do it like a skill based LLM inferencing at scale. So LLM inferencing actually happen almost every time. You have millions of users sending requests to your LLM server, and you have to respond to it. You have to plan for the scalability, for tolerance. When I read about NVIDIA Dynamo, I see that they actually consider all of these things. Like the scale and fault tolerance is at the heart of the design of the system, and it really blows my mind when I read about everything. I've been like 2 days now setting up this. So if it goes through the architecture, API server, so they support a couple of backends inferencing like VLLM, SGLang, and all of that. And they have their own router whereby when your request is coming in, so you can select the backend that you want to, and then KV cache. For people that are aware of LLM more, your transformer models really have this KV cache for every of it. The request token, you tokenize it, and you have all of this KV cache and everything, like a projection matrix. So it's really another separate topic on its own. So, but you have this KV cache, which is a kind of a bottleneck. You can't store all of it on the GPU memory. So they have this KV cache, offloading solution. I read this blog post as well about KV cache offloading, about their blog post, and it's kind of very nice. So all of this summarized together were actually what informed me to kind of try it out and see what does it do behind the scene and how it works. So I have my own setup on Google Cloud. So you can see, I have the decode worker and I have the, the prefill worker, and I have the front end where the requests coming through. So I think I have my setup automated in Terraform already and on GKE. So I have this inferencing directory and I have this manifest for Queen 3 model deployment. I have my YAML file. So I use the latest release. So if you go to the release, you see the release. So I have my front end components. I have the KV cache setup. I have the 5 replica for the decode. So there's two stages, right? You have the decode and you have the prefill. So you have the different separated workout for that, and you have to transfer a KV between your prefill, which is kind of compute intensive, and your decode is memory intensive, because you don't want to recompute your cache all the time. You don't want to recompute things all the time. You want to cache it on GPU memory, and like H100, you have like 80 gig memory, so you can run out of that quickly if you have a large context window models that's about like a million context window. So all of those things you can actually take into consideration and you in setting up your own, and then you can scale it up. So basically it's really amazing. It has a lot of features which I've experimented and have a couple of tests that I've run. I have these commands, and then it's had a lot of components that it relies on, like Kai scheduler, Volcano, for batch scheduling and all of those components that it really supports on. But I think it's really cool that you lay hands on it. I have example request that I've sent. I have it here. So if I sent it, what is cloud computing? So it's gonna give me the request response, and it tell me the model it used to send the response. And it's kind of a ChatGPT, open a high format, so you can send your model the messages. It supports to calling and all of that. You can see that in their release, right? So you see their release here. I follow their release notes. I see what is updated in the release notes, and I use that to inform what I set up. And I also follow the architecture design here and a couple of documentations and blog posts basically. So you have the backend that it supports here. You have the router, what does it do, and you have the planner, which is basically the one that do auto scaling based on your SLA, like first time to token and your inter token latency. So you can have all of those supported, and you have base load balance and SLA planning. You have your KV block manager for KV transfer. This is a native one. In my own setup, I support LM cache for my KV transfer. So I have LM cache enabled, and I have the cache, the cache block and all of that. But I cache it in the host memory, like a CPU RAM, right? You can cache it to like a persistent disk or file store or remote GPU direct storage backends through. So they have this thing called NXL library and CXU, which they use to kind of transfer. So kind of like an event driven basically. So I have a bunch of notes that I've taken in the process. You can see my current setup features, what they use each of these components for, and then all of that. And then my review I was trying to write about for this video as well, and a couple of other things that I plan to explore down the line. I'm still trying to explore it as well, honestly, and I'm also trying to run a couple of requests to do some stress tests. You can see my script here. I'm trying to run some stress testing on it, and it's trying to run some concurrent requests and see how much load it can handle down the line. Yeah, it's pretty amazing.